Up until now, we've been mainly focusing on explicit differentiation. And explicit differentiation is when you've got y equals, so we've got y equals, say, 2x cubed plus 3x. And to do explicit differentiation, we've got the y by itself, and then we've got terms in x or constants on the right hand side. So if we want to find dy dx, what we basically do is we find the derivative with respect to x of every term. So we go d dx of y equals d dx of 2x cubed plus d dx of 3x. So we find the derivative of every term. Now the derivative with respect to x of y is nothing more than dy dx. Derivative with respect to x of this first term here is 6x squared, and the derivative with respect to x of 3x is just equal to 3. So that's what we've been doing, and that's called explicit differentiation. Implicit differentiation is when we've got x's and y's intermingled. So if we've got, say, x squared plus y squared equals 25. Most of you will know that's the equations of circles, centre of the origin, radius 5. We want to find dy dx here. We could rearrange this and get y by itself, but we can use implicit differentiation. Now, there are certain steps which I'll go through at the end, but I'll just go through what you do. We find, just like we did up here, we find d dx of each of the terms, every term, so d dx of x squared plus d dx of y squared equals, let's get rid of that, looks like a not equal sign, equals d dx of 25. So that's the first step, just find the derivative of everything, evaluate each. This one's okay, d dx of the derivative with respect to x of x squared is just using the rule, is equal to 2x. Come back to this one, equals d dx of a constant is 0. Now how do we find the derivative with respect to x of y where we know y is a function of x? So we've got, if you like, something like a composite function, so we need to use the chain rule. So we've got derivative with respect to x of y squared equals d dy of y squared times dy dx. So we find the derivative of y squared with respect to y times dy dx. Now once again, if you look at the left hand side, you've got derivative with respect to x of y squared. If you could cancel these two dy's out, you would have derivative of y squared with respect to x. So you get the left hand side equals the right hand side. Now to do that, derivative with respect to y of y squared is 2y times dy dx. So I can now, instead of that, go plus 2y dy dx. I want to get dy dx by itself, so I've got to get that 2x to the other side. So you've got 2y dy dx equals negative 2x. I want to get dy dx by itself, so I divide both sides by 2y. And they will cancel each other out, and you get dy dx. And I think 2 will go into top and bottom is minus x on y. Now that means, graphically, that the gradient at any point on the circle is just the negative of the x divided by the y. So if this has the point xy, the gradient of that point is the negative of the x coordinate divided by the y coordinate, and that applies to every point on that circle. But anyway, that's by the by. The main thing is that how to do implicit differentiation, where you've got x's and y's intermingled in an equation. You want to find dy dx. The steps are these. Let's go through, and so these are steps, or what I like to call template. So there's a template. A template is just something you'll throw over, a method you'll throw over every example. You use the same steps. Template for implicit differentiation, and there are 4 steps. Number 1, find d dx of all terms. That's left and right hand side, so left hand side and right hand side of the equation. So you find d dx of all terms. Number 2, collect all terms with dy dx on the left hand side and all other terms on the right hand side. So basically up here we've found d dx of all terms, and then we've all the terms with dy dx, which is simply just that one, we've kept on that side, and we've taken the 2x over to the other side. Step number 3 is factor out dy dx on the left hand side. So you'll have dy dx outside of something equals, and there'll be something on the right hand side. So you'll have dy dx outside. You could have multiple terms in there. And the final step is to divide both sides by this factor here. So if we go a, divide the sides by a. So whatever's in there, you've got to divide right through by on both sides. And then that will cancel out and you get dy dx by itself, and then you'll have whatever's over there divided by a. Okay, so that's the 4 steps of the implicit differentiation. I went through them here and showed you an example. This rule will apply. We'll do some more examples in a minute in the next video, but this template will apply to all questions when you're asked to find the implicit differentiation.